Okay, what would that be again? Limit as, I'm using delta x. And okay, delta x goes to 0. Okay, then it'd be what? F of plus delta x, right? Minus f of x. And then we have this other form, because some people don't like writing delta x. We have the limit as h goes to 0. Then we have f of x plus h minus f of x all over h. And we just talked about how you got to be able to use both forms, right? You can't be scared of delta x. And then we have the alternative form, or the alternate form. And that's specifically when you have a c value, right? They give you an x value that you're supposed to find the derivative at. We can use this alternative form or alternate form. And this would be the limit as x goes to c of, what was that, f of what? X minus c. Okay, and here's your function. Here's your function evaluated at that x value. Here is the x value, and here is the x value, right? Okay, and then we have, let's see, let's go through some rules. Constant rule. What if f, or say y equals 3, what is y prime? 0. Constant rule, derivative of a constant is 0, right? Okay, and then after that, I think we had the power rule. And let's say we had y equals x cubed. What was y prime? Okay, and then in general, if what is d dx of x to the n power? Remember, that's the general form, any power. Nx n minus 1, okay? All right, we drop the power down because multiplier we subtract 1 from the power, right? Okay. And then we had something called like scalar multiplier rule, right? So if we have what's d dx of say 3x to the 4th, what happens to that 3 out in front? Yeah, we can basically bring this guy out in front, right? So we can be 3d dx, and we don't really do that all the time, but we think about it like this, so that we know that it's going to be 3 times now the derivative of x to the 4th, which is 4x cubed, and then you get 12x cubed, right? Okay. All right. What was after that? Oh, sum and difference rule. Okay, sum and diff rules. Okay, that is if we have, say, h of x equals f of x plus g of x. What is h prime then? Okay. And then let's say they give us something like this and they want us to find h prime of 4, right? Well, that's just finding h prime, which is right here, and then evaluating this derivative at 4, which would be like f prime of 4 plus g prime of 4. And we'll use that if they give us a table or something, or they'll just tell us what the values equal. Okay, I think we did that in our homework, right? In our book assignment. Okay, sum and difference rule. Obviously, that could be plus or minus, plus or minus, plus or minus. Okay, that just means if you have terms, you take the derivative of each term. Okay, after sum or difference rule, what do we have? Product rule. Okay, I'm going to say h of x equals f of x times g of x. That is definitely a product, right? We have two functions that we can't just like distribute really quickly or something, or rewrite. So we can use the power rule, And then we want to find the derivative, h prime. Okay. Again, we know there's multiple ways to do this, right? All right, so let's go with one of them. You want to go f prime x times g of x, okay, plus what? Okay, you want to go that way? What's another way? And since multiplication is commutative and so is addition, we know we can flip those and flip. I mean, it's pretty easy, right? Okay. Product rule, not too bad. What's one after that? Quotient rule. Okay, say we have h of x equal to f of x over g of x. All right, what is h prime? I'm going to be fancy and use brackets, square that. Okay. Is that it so far? All the rules we got? All right. So for fun, if h of x equals 4 f of x all over 3 g of x minus, let's say like 2 s of x. Try saying s of x fast. Good luck. What's h prime? Okay, so that's still low d high because the major outside function is quotient, right? So low d high. Okay, so we're gonna go through that process, and I'm putting parentheses around this because I know it's going to be a multiplication problem, right? 3. You said 3 g of x minus 2 s of x. S of x. What's the derivative? 4 times the derivative of f of x. What's the derivative of f of x? F prime x. So that's low, d high. The derivative of upper function, well, it's just a scalar multiplier times f of x. Well, what's the derivative of f of x? F prime x. Okay. Minus. So 3 g prime x. Okay, good. S prime of x. And parenthesis. When in doubt, parenthesis. And extra fancy using brackets, squared. Or AROC. So average rate of change, slope of the secant line. What do we need? We need 2 points, right? This is always going to be over an interval. And we need 2 points. If f of x equals some polynomial function, find the average rate of change. I'm going to say AROC, just for fun, average rate of change. Find the average rate of change on or over. And let's go, what's your favorite interval today? -2, 4. Now we need 2 points. So this is going to be the average rate of change is equal to, let's say, f of 4, which would be your y value, minus f of -2, all over 4 minus -2. That's just slope, right? Okay. Now on the side over here, scratch paper, you might be finding f of 4. If somebody would calculate that real quick, please. And then on the side over here, I might find f of -2. And then for convenience factor, I'm going to plug those in instead of writing it all out, right? Confirmation, I don't trust him. I don't trust anybody. I don't think you're special. F of -2?
-4.
You sure?
Yeah.
Positive. You guys are going to take his word for it. Nobody's checking this? It is? Okay, good. All right, so f of 4, -4 all over, what is that, 6 then? 24 over 6, which is what? Is that 4? What's the instantaneous rate of change then? Whoops. And we call it IROC. Instantaneous rate of change, IROC for short. Instantaneous rate of change is the change at one moment in time. Yeah? Which means we have to find the, which is the derivative. Yeah. Instantaneous rate of change is just the derivative evaluated at that 1x value, right? Okay. So we have to find f prime, and we'll call it c, right? Because f prime is c, the derivative at one moment in time. Okay. It's the slope of the tangent line because it touches that function in one spot, right? We have a way to do that, the derivative. How things are changing at one moment in time. How do we know that? It says instantaneous. Keywords, guys. Okay. What is the instantaneous rate of change?
X cubed plus 3x squared minus 7x plus 49.
Oh my goodness. X cubed what?
Minus 3x squared plus 7x minus 49.
You can say whatever you want to over here. I don't care, right? The derivative, right? Goodbye, constant. At x equals
20.
No.
5.
42.7. Okay, and then like these instant rate of change, this average rate of change, obviously we might have t as our variable because we're talking about time, right? If we do make this an application problem, which we will shortly, okay? Well, instantaneous rate of change, instant, 1x value, it is the derivative. Average, secant line, 2 points, interval, all right? F prime was that 3x squared minus 6x plus 7. So then f prime of 42.7 is equal to, go ahead and use your calculator if you want to on that one. And what do we always go to? At least 3, right? At least 3. Truncate around. You can use more if you want. It's up to you. Jack, what do you got?
5,220.
Like that? All right, suppose f of x equals x squared over x squared minus 9. Right away, tell me some things you know about this function that we might need to keep in mind. Okay, then what do you get? So what does that mean? Why are you factoring the bottom? What are you looking for? Well, let's find when we have a horizontal tangent line. All right, so when you hear the words horizontal tangent, you got to remember it's not horizontal asymptote, right? Horizontal tangent. What do we do to find the horizontal tangent line? We should know what we're looking for before we start doing stuff. So what equal to 0? You said it. So what equal to 0? The function, set the function equal to 0? Yeah, I would find when f prime of x equals 0. That's what we're doing. We're looking for, okay? All right, we've already gone over this. Let's review problems, right? So f prime x equals, okay. What do we got? Keep going. All right, let's simplify. So that'd be 2x cubed minus, not 9, 18. 18x. And then was that minus 2x cubed again? Which means x squared minus 9 squared. It's kind of convenient, huh? Simplifies kind of nicely, I believe. And it looks like our simplified derivative will be negative 18x all over x squared minus 9 quantity squared. All right, let's take a second and let's talk about this derivative. What do you know about this derivative? Yeah, it's just 3 and negative 3, guys. Well, when is this fraction equal to 0? When is that derivative equal to 0?
0.
How'd you get that?
Top equals 0.
Yeah, okay, so if we want to know when a derivative equals 0 and our derivative is a fraction, aren't all fractions equal to 0 when the numerator equals 0? So let's take the numerator, set it equal to 0. And then x equals 0 after I divide by my negative 18, right? So when x equals 0, we have that horizontal tangent line. And obviously, if I ask for the point, we could plug 0 back in. And guess what? What's f of 0? That's 0 also. Okay. So it actually occurs at 0, 0. That horizontal tangent line occurs at 0, 0. Not too bad. Questions on that? We're good?